Hello, Year 10, Mr. Thompson here. You've obviously found this video on my YouTube channel, and this is how you can expect to get access. A lot of the work, it does mean that you can go back if you miss anything or you fall behind and check things out. You will need to start taking notes. We are starting a new unit on forces. It's unit 5 in the GCSE, both the physics and the combined. And the work that we do covers both the content, so you're all getting the same work to start with. Today's lesson is probably quite a short one, quite an easy one. It's just an introduction to the forces. Go back to what you might remember from your work in year 8 on forces, the last time you did it, and just to make some general notes on the introduction to forces. A couple of videos for you to watch and finish off with a little quiz which will assess how much you've understood. And it is mandatory, you must do that at the end of the lesson, and that's the way that I can monitor and check that you've actually done the work. I'll give you 2 days to do it, so it must be in before next lesson on Friday. So let's begin. Let's check the spec. Let's have a look at what you must learn. You must know what scalar quantities are, that they have magnitude only. You must know that vector quantities have magnitude and associated direction. A vector quantity may be represented by an arrow. The length of the arrow represents the magnitude, that's the size, and the direction of the vector quantity. If you want to pause this video now and copy those 3 points down. Okay, next thing I want you to do in your book, or if you're doing electronically, do it electronically, is just give you some idea of scalar and vector quantities. So in the middle, there's some mixed ones here. I'm just going to tell you a little bit about each one. So number 1, mass only has size, so it is a scalar quantity. You can't have negative scalar quantities as well. You can't have minus mass. Number 2, distance again is a distance. It's a scalar quantity. It only has size. Whereas displacement is a vector quantity. That means how far away you are from a particular point. So it could be a minus number. That means it's a vector quantity. Speed is a scalar quantity, just a judge of how fast you are going, whereas velocity is, as we'll find out in this video, how fast you're going in a particular direction. 6, energy, which you've studied, is all about how much energy you have as a scalar. It only has size. And time only goes in one direction. You can't go backwards. Number 8 is power, which is a scalar quantity. And 9, momentum, we'll learn about in a month's time, has a direction as well. It depends on which way you're going. Current is a vector quantity. We did in electricity. You can have currents positive and minus, different directions. And force, also we're studying today, has size and direction. If you want to make a table, pause the video, make a table of scalar and vector quantities. Let's have a look at the difference between speed and velocity. Remember, speed is a scalar and velocity is a vector. So if you're traveling at a certain speed, you can describe the speed about how fast you're going. It doesn't matter which direction you're going. If you describe the car's velocity, it matters which way it's going. In this case, it might be going east. So if you said east was positive, then west would be negative. So you can indicate it with a sign. That was quite straightforward, I hope. The next thing you need to understand is the difference between contact and non-contact forces. Basically what it says it is. If it's a contact force, then they are touching each other. If it's non-contact, then they are separated. So you need to know examples. I'm going to ask you to write a table here, pause the video, of contact, non-contact. So contact includes friction, air resistance, tension, normal contact force, things that make actual touching. Whereas non-contact force, good examples are gravity, electrostatic, and magnetic. These things don't need to be touching. Force, remember, is a vector quantities, and you should be able to describe interaction between pairs of objects. So if you want to make some notes on this page in your book. Okay, balanced and unbalanced forces, it provides us Newton's first law. Isaac Newton said, basically, a body will remain at rest or continue to move at constant velocity as long as the forces acting on it are balanced. You need to write that in your book as Newton's first law. So for example, here's a little example. If it's an unbalanced force, it will make him accelerate. So as soon as he puts his foot on the gas, he will start to move forward and accelerate forwards. If he puts his foot down on the brake, he will start to slow down and eventually stop. To describe that, let's have a look at 4 scenarios of a car and describing the forces on this Mini. And we're going to have a look and see what they would do. So in the first instant, there is an unbalanced force to the right. It will accelerate. The second one, you can see there is still an unbalanced force. The left force will probably be air resistance, trying to slow it down, but it's a smaller arrow, so you still be accelerating forwards. Whereas the third one, you can see the arrows are the same size, but in opposite directions. So it will stop accelerating and move at a steady speed. If you take your foot off the gas, as in the last one, then and put your foot on the brake, maybe you will start to slow down or decelerate. Again, draw this in your book, please. Okay, you've obviously found my YouTube channel, and I have created a playlist, an SB Year 10 playlist. So this video is in there, and there are 2 other videos I want you to watch, which are not my videos, but excellent videos, much better than I can make. I'd like you to finish by watching those 2, and then finish this lesson by completing the little quiz to see how much you've learned. So the videos I want you to watch, I've sent links in Show My Homework, are forces that can cause change, and balanced and unbalanced forces. So you can click on those from the links in Show My Homework. Any feedback you can do by email, please, or by comments on Show My Homework. I have not created the Teams chat. We will do that in the future once everything settles down with Teams. Hope you've enjoyed the lesson, boys, and I hope you're well and stay safe. Goodbye for now.